So AB and AC are these two vectors. We just do B minus A to find AB and C minus A to find AC. So the equation of the plane is R, the moving point on the plane, is equal to the fixed vector, fixed point, which is A we used in here. So 3, 5, minus 1 plus lambda, the first direction. So this is minus 1, minus 7 and 5, and plus mu, the second parameter of the direction 1, minus 2 and 1. Alright guys, so this is how we find equation of a plane when we're given 3 points. So what do we need? Once again, we need one fixed point and the two directions on that plane. So two vectors we find. This is how we find equation of a plane, guys. I hope this is clear. This is obviously exercise 9b and this is exercise 9d question number 12, as I think this is 9d question 12. Okay, right. Move on to the next stage. We come back to these questions again and again. And the next part we're looking to do, once we find equation of a plane passing through 3 points, we're going to see if another point, fourth point, lies on that plane or not. I mean, this could be exercise 9b question 3, or this is part of question number 12 of exercise 9d, which we're doing. Because this is a point D, that's the equation of the plane, and we're going to figure it out if this point lies on the plane or not. This is basic algebra. Think about it for a second. Let me set this up, then we talk about it. So this is the parametric form of equation of the plane. All I did was just collected the 3 top components together, 3 middle and 3, and we're going to check if this point lies on this plane. So guys, what are we expected to do? We equate the two like simultaneous equations in algebra. I've been telling you this from beginning. Any point of intersection or any verification of line point, something lies on the line or plane, just equate them and see, solve them simultaneously rather. So guys, we're going to get 3 equations, one from here, second from here, and we solve these 2 equations to find lambda and mu, and we see if that lambda and mu verifies this third part or not. Okay, so let's do that algebra ourselves, please. Okay, DIY, I'll just give you a chance. So equating the first 2, top and the middle, I've got these 2 equations. I would like you to solve these 2 equations simultaneously and find lambda and mu. Okay, pause for a second as well. Okay, so we got these two horrible looking numbers. I just put them in the calculator and this is the numbers I got. So what I'm going to do now, guys, I'm going to put these numbers into this third one and see if this matches with -3. If it does, the point will be on the plane. If it doesn't, point will not be on the plane. So guys, can you verify that for me, please? So this, I think, gives me -9 minus 22. So 3 over 9. I think it gives me 3 over 9, which is not equal to -3. What does tell me? This point does not lie on the plane. Or in other words, guys, points A, B, C and D are not coplanar. They're not on the same plane. And the next and the most important thing in vectors up to this point is we're going to learn how do we find angle between 2 lines, 2 vectors. That will be, extended to 2 planes later on. And for that, we need to understand a very important concept in vector geometry is scalar product or the dot product of vectors. Guys, if you've got 2 vectors A and B, we have to find the angle between these 2 vectors A and B. So where is the angle? The angle is this, that theta. Okay, so we derive one way of multiplication of vectors. We call them dot product or scalar product. A dot B is equal to magnitude of A times magnitude of B and times cos theta. And we can rearrange this equation to find the angle between the 2 vectors. One very important point for you to understand over here, guys, if the vectors A and B were like this, they'll look exactly the same but for the direction. But now if we join them here, this is not the angle theta which this dot product is going to give me. Really important, what you have to know, that the vectors have to start from the point where this angle you want to find, guys? So what you need to do, guys, if you put this vector A, bring it parallel, draw it like this. Okay, so this is the theta. This time your dot product is going to give you. Okay, really important you understand. You got to have the vectors going away from the point where the angle is made to be able to use this dot product formula. But if you want to find the acute angle, always, if the question asks you to find the acute angle, all you have to do is, once you rearrange this, this will be A dot B over magnitude of A, magnitude of B. So to find the acute angle, what you're going to do, you're going to take the modulus of all of this. That means if you want to find the acute angle, you will always take the positive value of this cos theta. Okay, the modulus of all this. Fairly simple. And how do you find that A dot B is very simple as well. I'll show you how do you work out A dot B. So guys, here's my example. So let's work out the angle between these two vectors. Okay, first of all, magnitude of A is Pythagoras. 1 squared plus 1 squared plus 1 squared is equal to square root 3. Hope I'm getting this right. Magnitude of B is 2 squared is 4, 7 squared is, or minus 7 squared is 14, doesn't matter. So 53, and 9, it is 62. I think I've got that right. Okay, right, guys. So the cos theta is equal to, really important, this is A dot B over magnitude of A, magnitude of B. And if you want to find the acute angle, I'll just do the modulus of all of this. But first important point, you should ask me, how do we work out that A dot B? I know this. Okay, so A dot B is fairly simple, people. What you need to do is, you have to just multiply these two vectors, the corresponding items and elements, and add them. So A dot B is equal to 1 times 2. Remember, I'm just multiplying these two, plus 1 times minus 7, and plus 1 times 3, and this gives me 2 minus 7 is minus 5, and 3 plus 3 is minus 2. Okay, so guys, my cos theta, if I come back here as well, this will be cos theta is equal to, if I want to find acute only, I use this modulus of that, and that is over root 3 times root 62. Put this in the calculator, work that out. And I want to do, guys, whatever the angle is, this same, let's work it out first. Okay, go on. So this is 98.4 degrees. If you do not put this modulus, obviously you can't put modulus in the calculator. So if you put this negative 2 and this, 98.4 degrees, but if you just put the positive 2, because you know modulus cannot be negative, the answer will be something 81.6 degrees. Okay, so that's the acute angle. This is the obtuse angle between the two lines, and you can understand this, that's obtuse angle, and this will be the acute angle if you have to find the acute angle only. Okay, doesn't matter, guys, this is fairly simple. Now what I'm trying to say to you, if these are the two equations of the lines, okay, in 3 dimensions, then how do you find acute angle or any angle between these two lines? Is the same thing, guys. What do we just do? We pick up the direction vector of the first line and find the direction vector of the second line, and that is the two vectors we're going to be using. I have used those two vectors, same. So guys, acute angle between these two lines is the acute angle between these two direction vectors, which we worked out like this. And this was exercise 9D, question number 1C. You can practice more parts of this question, and the answer is 81.6 degrees. Okay, just pick the two direction vectors, find their dot product, okay, then find the magnitudes, put that in the formula, and work the answer out. Right, this is how we find angle between two lines. All right, we use scalar product. All right, guys, the next important concept we need to learn in vector is the normal vector. A normal word you've used in your A-level maths as well, which is the perpendicular to the tangent we use in normal. Guys, normal actually is, if you do physics, you do normal direction, you've done bearings, you've done normal there as well. Normal is the perpendicular to the vector. I've drawn two vectors there. If I write perpendicular to this vector, which is not on the plane, going into the plane or going out of the plane, this pencil will be perpendicular to this first vector, and this pencil is perpendicular to the second vector as well. Because what I'm trying to say, that normal to all the vectors you draw on that plane will always be in the same direction. And this is the uniqueness of any plane, people. You can define a plane in terms of its normal vector, because normal vector to every plane would be different, will be unique. If normal vector to two planes is the same or in same direction, then those two vectors are parallel. Okay, so we're going to be using this now to define our planes later on. Okay, so normal vector is the perpendicular vector to the plane which is going into the plane or coming out of the plane. Okay, it is not on the plane itself. Remember, this pencil is on the plane, so its normal cannot be this. This pen is not, it is perpendicular to this pencil, but this is not the normal to this pencil. Normal is perpendicular, which is not in that plane, which is going into the plane or coming out of the plane. Okay, that's normal vector. So now we come on to the use of this normal vector, guys. We can write vector equation of a plane in a different way if the normal vector is given. This N stands for normal. Okay, this is exercise 9D, question number 2C. So it says write equation of a vector which passes through this fixed point. Okay, and which is perpendicular to this vector, or this vector is perpendicular to that plane, or this vector is normal to that plane, guys. How do we work out equation of that plane now? Very simple. It is R is the fixed point. We do R dot A, N, the normal, is equal to A dot N. This is the equation of the plane in normal form. I'll repeat, R is the fixed point where it stays, dot N equals A dot N. I'll show you how do we work that out then. What does it look like afterwards? Right, so we make use of our dot product again. Let's find A dot N, which is 2 times 1 is 2, add 0 times 3 is 0, and minus 3 times 4 is minus 12. So the answer is minus 10. Okay, remember, very important, how do I get that from? This is 2i and minus 3k, so j element is missing, so that's 2, 0 and minus 3. So equation of this plane would be r dot 2, 0, minus 3, nope, sorry, r dot n, so r dot 1, 3, 4, okay, equals minus 10. This is another way of writing equation of a plane. Much easier, much simpler, and this is got more uses than the equation of the plane which we found in the first part, which is like this. Okay, this form of the equation of the plane is obviously, we need to know it, but this form of equation of the plane is better. It's got more uses there. Okay, so moving on from here, right. So this is equation of the plane. Now guys, what does it actually do? It helps me to find the Cartesian equation of the plane as well. Cartesian equation when we use x, y, and z. Guys, R is the moving point, and in my Cartesian plane, we use R as x, y, z. Okay, so time dot product that with 1, 3, 4 equals minus 10. So see what happens, people. Dot product of that will be x times 1 is x, plus 3y, plus 4z is equal to minus 10. Isn't that even neater, people? This is equation of the same plane. Okay, so this is the equation of the plane, and this is also the equation of the same plane. This is the Cartesian equation, and this is the normal form. So what actually does, if you're given with Cartesian equation of the planes like this, you can generate the normal vector from there. And these are question number 9b, question 2. I would like you to try. They would give you equation of the plane like this, and you will expect it to probably find the normal vector from this. What's normal vector from there is, guys? 1, 3, and 4. The coefficients of x, y, and z. Right? So we've done question number 9d, part 2c, and we could try question number 9d, 3 and 4 as well. Let's have a look at one of them. So 9d question 4, it says the plane has equation r dot n equals k, where n is this. So find the Cartesian equation of the plane. So guys, that will be x times n1, n1x plus n2y plus n3z is equal to k. Okay, that's Cartesian equation of this plane, right? Okay, so another application of dot product, which I should tell you right now at this stage, which is in exercise 9b mainly. This is that the dot product or the scalar product of two perpendicular vectors is 0. And this is very simple to guess, people, because dot product involves magnitude of A, magnitude of B times cos theta, and if angle is 90 degrees, guys, cos 90 is 0, so dot product would be 0. Okay, and dot product of two parallel vectors, okay, because angle would be then either theta would be 0 degrees or theta would be 180 degrees. Okay, and what happens in cos, people? Okay, the dot product will be, if theta is 0 degrees, parallel vectors most likely, so cos 0 is 1, so dot product would be A dot B, in that case would be mod A times mod B. Okay, so this is another application which we can look in some questions from exercise 9b. Right, so after working out angles between two lines using the dot product, we worked out angle between two lines. Okay, we're going to move on now to work out angle between a line and a plane. Okay, this is exercise 9d, question number 5 and 6. I've copied question number 5, so I would like you to have a look at these questions. We work on it together. So pause for a second. Okay, let me just try and make you understand the geometry of this now, people. This blue thing is a plane, and this red is a line there, and we're going to find the angle between this line and this plane. Let's say we're going to find this theta. Okay guys, so what do we know? And I told you that there is uniqueness about planes, that every plane will have normal vector, unique normal vector, and I've been given this normal vector there, which a normal vector would be this vector. Okay, so this is the direction of the line, and let's say this is the fixed point which is on the normal as well as on the line. Okay, obviously that fixed point can be different, but this is the direction of the line. All right, people, and what we need to do, if I use my dot product of the direction and the line, I will get this angle. Let's call it alpha. Then how do I find angle between the plane and the line? Would be 90 degrees. 90, take away that. Okay, or what we can do, people, we can use different formula to find cos theta. Instead of cos theta, we can use sin theta as well. Okay, let's see, how do you figure that out? Alright, so looking at this triangle, you can see this is a normal vector and this is the line, the direction of the line B. So guys, if I have to find this angle, this becomes sine. If I'm using these two sides, this is opposite and hypotenuse. Okay, so sine theta, the angle between the line and the plane, would be equal to, same rule, people, this is B dot N, the scalar product, divided by modulus of B modulus of N, and we'll do modulus of that as well, because that will always give me the acute angle. Or you can do it in 2 steps anyway, people. You can find this angle first, acute angle, and then take away from 90. Okay, work that out. Let's see what the angle is. So theta, I think, is equal to let's work it out, guys. 4.3 degrees for me. Okay, check if this is right or not. I'm sure you match the answer with me. So guys, once again, what did we learn? Angle between line and a plane. When plane is given to you in the normal form, and geometry, if that's plane, this is a line, and normal is a vector coming out of that plane. Okay, obviously you're imagining this in 3 dimensions. Okay, and I want to find this angle. Okay, and no dot products normally would have given me this angle, so I can find that angle, take away from 90 to find the other angle as well. Okay, moving on, and we do now this is, we've worked out angle between 2 planes now in the normal form. So guys, we'll discuss that in a minute in geometry as well. Okay, let me just set it up for you. So these are the 2 planes, people, the blue and the red, and we have to find the angle between these 2 planes. That's the angle we're looking to find. So what do we know in here, people? Everything, I did tell you that before. Every plane has a unique normal. So let's draw the normal from this plane, and let's draw the normal from this plane as well. and I know both the normal vectors. One of them is this and one of them is this. Okay guys, if I use my dot product to find the angle between these two, obviously if I do not use the modulus, I can get this obtuse angle. Okay, if I get that angle alpha for argument's sake, then how do you figure out, guys? This is 90 because it's normal, that's 90. So this is a quadrilateral with two angles 90, one angle is alpha. So this will be your 180 minus alpha. It's really important, people. Use dot product of two normal vectors, okay, and find the angle between them. And then obviously you do not use modulus if you do not looking to find acute angle. Acute angle will be this, but this angle, if in this form, is whatever. Because if you don't use normal, find the angle. Don't use the modulus in, so just use cos theta is equal to a dot b over modulus of a modulus of b. Don't use the whole modulus because that will give you the acute angle. Okay, so this will give you this angle alpha here, right? Then take away from 180, work that out and match the answer with 9. So this comes out as cos theta equals minus 10 over 27, and which calculator gives me as 111, 112, let's say, 3 significant figures. And this is this angle, by the way, that's alpha there, 112. So if I take away from 180, so my theta equals 180 take away 112, which is 68 degrees. Okay, so I could have done one more decimal place, but that's all right, guys. Important is to understand the concept. So once again, angle between two planes, what do? We work out the angle between two normals, then take away from 180 to find the angle between the two planes. Okay, moving on then. Okay, guys, the next thing you need to cover is intersection of the three lines in 3 dimensions. Okay, and there's a flowchart given in the book which I'm going to show you just now, and the questions 9e, 1, 2 and 3. Okay, the flowchart is this. It says write the equation in column notation and set them equal to each other. Reason, people? Intersection, simultaneous. We set them equal to each other. Okay, so write 3 linear equations involving lambda and mu, equating the top parts, middle parts and the bottom parts. Okay, try to solve the first 2 equations simultaneously. If it doesn't have a solution, lines don't intersect. If these 2 equations have a solution, okay, then what do? Solution exists, and do this solution satisfy the third equation? So lambda and mu, when you get, put them into the third equation if they satisfy. If they do not satisfy third equations, still lines don't meet, intersect. If they satisfy, the lines do intersect, substitute the value of lambda and mu in any of the 3 equations to work out the point of intersection. Okay, so we will be doing this question. It's basically algebra from here, guys. So these are the 2 equations I've selected. This is question number 9, exercise 9e, question number 3. So I would like you to follow that, pause the video, go back and check, and then do this step please for me. Okay, these are my 3 equations. Check for yourself if they're right or not. If they're right, guys, work it out, solve the first 2, putting the calculator, work it out, and solve it without calculator, find the values of lambda and mu, then we test in the third one. So I think using these 2, guys, lambda equals 2 and mu equals 1, I get, okay, 2 times, yeah, that's right. Okay, then I substitute these into the third one, and this is 6 plus 1, and as right side is 2, and they're not equal to 2, guys, according to my calculations. If they're correct, these 2 equations, these 2 lines given in vector form, they do not intersect. Okay, so there are a lot of uses of this intersection. I'm going to talk about that in a minute. Video is getting longer, so I'm going to be quickly finishing it off with 1 or 2 more things. Alright, the next thing I'm going to talk to you about the intersection of the line and a plane. Let me just explain to you 3 scenarios. There's a possibility that, obviously, you imagine this in 3 dimensions. A line cuts the plane at a point. Okay, one unique point. There's a possibility number 2 that line is parallel to the plane. Okay, and there's a possibility line is parallel and it's inside the plane. So guys, what happens if you solve this equation simultaneously? Intersection means simultaneously. In this case, I will get a unique solution. In this case, I will get no solution. They'll be inconsistent. Okay, and in this case I will get infinite solutions because they meet at every point. Okay, if lines in the plane. So what we need to do, guys, we need to solve this equation of the line and equation of the plane and see what happens. And this is exercise 9, question number 5, which I'm trying, and solve these two equations simultaneously, please. Thank you. So the question is, how do we solve this equation simultaneously, guys? So what do? We put this value of r from the line into the plane. Okay, and solve them. Let's see. So this value of r is 3 plus 2 plus lambda. Okay, 3 plus lambda as well, and minus 2 plus lambda. So dot of that would be with 1 1 minus 2 and equals to 1. Guys, let's see, we formed the equation there. All right, so let's see what do we get here, guys. So you can find the dot product of these two and check. So if you've tried, let me just do that with you, guys. I get 2 plus lambda plus 3 plus lambda. Remember, I'm multiplying this with this, and then plus 4 minus 2 lambda, and that gives me, and can you see lambda vanishes, people? That means there is no solution for sure, or there could be infinite solution. What happens is this gives you 5, 4, 3, 7 and 9, and that's not equal to 1. So guys, there is no solution. Okay, and if lambda vanishes and I get 1 equals 1, there'll be identity. That means whatever the lambda is, 1 will be equal to 1 always. Then will be infinite many solutions. So guys, what does it do? This is exercise 9e part 5. That means this line does not meet this plane and it's parallel. This is this case. There's no solution. Remember, if it was this case, I would have got same number here. Let's say I would have got 1 equals 1. Then there would be infinite many solutions there. So in this particular case, there's no solution. And if this was that case, I would have got one value of lambda from here, put in here to find the point of intersection. Okay, so this is about intersection of line and the plane. It's 20. Alright guys, I've decided I'm going to finish this video with this last thing. This is skew lines, guys. Skew lines is a concept of 3 dimensions. That's a line. This is a line. They meet in 2 dimensions unless they're parallel. When the skew lines, people, in 3 dimensions, what happens? The lines are not parallel, but still they don't meet. Can you see? They don't meet. They're not parallel. They don't meet. These are skew lines. Okay, so we're going to figure it out if lines are skew or not. This is exercise 9e question 8. Have a look and we work on it together. Right, so for step 1, people, I've written down these equations in parametric form. Let me explain that to you quickly. I'll leave the algebra to you. Okay, it's 29 minutes already. So guys, what did we do over here? Listen very carefully. You equate that to lambda. Okay, then you write equation. This is x minus 0. Okay, then x minus 0 over 3 equals lambda. Just take it to the other side. You get x equals 0 plus 3, 0 minus 3 lambda. Okay, so that's 0 minus 3 lambda, right? This is 0 minus 3 lambda. So this one will be minus 1 plus 5 lambda is the value of y, and z will be 2 plus 4 lambda. Okay, for L2, for write as a fraction first, this is 1 there, and this is take away 0 one more time. This is 0 plus mu. This is just a mu, 0 plus mu, and then 1 minus 2 mu, and then minus 5 plus 2 mu. So people equate these two equations now to find the points of intersection and see what do we get. Do that for me. So I quickly checked, guys. When I put this in the third equation, they do not match. That means the lines do not intersect. The only thing left for me to verify now, the lines are not parallel as well. So look at the direction vectors of the first line and the direction vector of the second line. Are they scalar multiple of each other? No, they're not. Okay, because if I divide this 4 by 2, I get 2. If you divide 5 by 2, I don't get minus 2. They're not scalar multiples. So lines are not parallel as well. They do not intersect, not parallel. So these lines are skew. Alright gentlemen, alright everyone, I will finish this video now. It's gone too long. Okay, and thank you very much. Bye.